Okay, hello, welcome to today's lecture. So today we're going to start chapter 8, 8.1. We are on page 1. We're going to talk about the length of functions or graph of functions in two-dimensional space. Length of curves. So suppose you have a function in xy plane. So this is your x-axis. This is your y-axis. And suppose you have a function, graph of the function is given like this. This is function f of x. Suppose you want to know what's the length of this graph between A to B. What is this length here? What is this measurement here? So what is this length? The formula for the length of curve of function when x ranges between a to b is given as L equals to integral. Your x ranges between a to b, so lower limit is a, upper limit is b, and you have square root of 1 plus, you take the derivative of your function f. After you took the derivative of your function, you raise it to the second power. 1 plus the derivative of the function raised to 2 dx. So let's go over one example together. Example. So suppose you have function, let y squared is equal to x cubed. Question says find the length of the curve between these 2 points. The first point is 1 and 1, and the second point is 4 and 8. There you go. So first of all, we need our function f of x. What's given? Y squared equals to x cubed here. Since y squared is equal to x cubed, y is equal to square root of x to the third square root. It means that your y is equal to x raised to 3 halves. So our function is f of x equals to x raised to 3 halves. The first coordinate is 1, so this is your A. The first coordinate is 4, this is your B. You have your lower limit, you have your upper limit. Now you have to follow the formula. You know that the length is equal to x ranges between 1 to 4 square root of 1 plus the derivative of the function raised to the second power dx. So since we need the derivative of the function, inside parentheses, we have to take the derivative of this function. F prime of x is equal to, you have an exponent, 3 halves, it is 3 over 2, x raised to 3 over 2 minus 1. So the derivative of your function is 3 halves, x raised to a half. Let's plug that in. This derivative goes inside parentheses. So here you have 3 halves x to a half raised to 2. There you go. Let's simplify this integral and try to take the integral. L is equal to integral 1 to 4 square root of 1 plus 3 divided by 2 raised to the second power. 9 over 4. X raised to a half is now raised to 2. So you get rid of denominator 2. You get x dx. So let me write this here for you. X raised to a half raised to 2. We can cancel out 2 and 2. It is equal to x. This integral is not very hard to find because you have square root of. Now you can use u sum. U sum. If your u is 1 plus 9 over 4x, du is equal to 9 over 4 dx. So you can multiply by 9 over 4 and 4 over 9. So the length is equal to 4 over 9 integral square root of u du, which is 4 over 9. Now you have u raised to a half, so you get 1 divided by 1 plus 1 over 2. What was your u? U was 1 plus 9 over 4 times x raised to 1 plus a half, and your x ranges between 1 to 4. Very well, let's simplify this. We get 4 over 9 times 2 divided by 3 times, so here you have 1 plus 9 over 4, x is 4, so you get 1 plus 9 raised to 3 halves minus 1 plus 9 over 4 raised to 3 halves. If you do the algebra, this is equal to 8 over 27, and in the bracket you have 10 raised to 3 halves minus 13 over 4 raised to 3 halves. After simplifying the whole thing, your outcome is equal to, I'll leave it as just radical. This can be written as 80 over 27 bracket. Here you get square root of 10 minus, so if you factor out 10 from this, you get square root of, let me just write down what we have here. Bracket and need a little bit of space. So 13 over 4 raised to 3 halves, which is equal to 8 over 27, 10 square root of 10, minus 13 over 4 square root of 13 over 4. But here, since you have on your denominator 4, square root of 4 is equal to 2, so you get 1 over 8. Now you have 13 on your numerator, so you get 13 over 2. This is the length of your chain.
Professor, I have a question.
There we go. Let's continue. So we are on page 2. Another example for you. Suppose you have this function. Let y squared be x. Question says find the length between these 2 points, the origin and point 1 and 1. Very well. You might say, okay, since y squared is equal to x, my y, then y is equal to square root of x. So now I want to take the integral between 0 and 1. Length is equal to the integral 0 to 1 square root of 1 plus the derivative of the function raised to the second power dx. Okay. There you go. So here you have your function. Since y is square root of x, the derivative of the function is equal to 1 over 2 times square root of x. Let's plug that in. Your L is equal to integral 0 to 1 square root of 1 plus 1 over 2 times square root of x raised to the second power dx. There you go. Let's continue. L is equal to integral 0 to 1 square root of 1 plus 1 over 4x dx. Okay, I'm getting a complicated integral. Why is that? My L is now equals to 0 to 1 square root of 4x plus 1 divided by 4x dx. Which method works here? What should I do? Which technique helps me to take this integral? Okay, now I expect you to ask a question. Can we change the variable when we find the length of the curve? So what I mean by that? I mean, instead of using L equals to A to B square root of 1 plus f times x squared dx, can I write it this way? L is equal to the integral c to d square root of 1 plus g prime of y squared, g prime of y squared dy. I'm taking the integral with respect to y, so when I'm using the length formula inside the radical, I have to take the derivative of the function with respect to variable y. So in situations like this, when you take the derivative with respect to x and you plug that in and you get a complicated integral, you can switch to this formula, finding the length of your function with respect to variable y. Okay, let's erase this and try to take the integral with respect to variable y. So y squared is equal to x. It means that gy is equal to y squared. You rewrite your function in terms of y. So g prime of y is equal to 2y. L is equal to integral c to d square root of 1 plus the derivative of y squared dy. The derivative of g with respect to y squared dy. The derivative of g with respect to y is just 2y. What is c? What is d? Remember that. The first coordinate is a, the second coordinate is c. The first coordinate is b, the second coordinate is d. The change in y values, second coordinates. Very well, L is equal to integral 0 to 1 square root of 1 plus 2y squared dy. This is equal to integral 0 to 1 square root of 1 plus 4y squared dy. Very well. Here you can just work with your trig substitution. Remember that. For this integral, you're going to use trig sub. They can take 2y as tangent theta. And you take the derivative of both sides. 2 dy is equal to the derivative of tangent. Tangent was sine over cosine. Then you take the derivative. It is sine squared minus cosine squared plus cosine squared. So you get 1 divided by cosine squared, which is secant squared. So you get secant squared theta d theta. Very well. Your L is equal to integral square root of 1 plus tangent squared theta secant squared. So here your dy is a half, so we need a half secant squared theta d theta. We all know that square root of 1 plus tangent squared is equal to secant squared. So from the integral, you get a half integral secant theta, secant squared theta, d theta. This integral is equal to a half integral of secant cubed theta, d theta. Okay, now our integral is equal to 1/4 bracket secant theta tangent theta plus ln. So I need to do this now. Maybe write it down here. Plus ln of absolute value of secant theta plus tangent. Very well. So remember that our tangent theta is equal to 2y. We need to find the lower and upper limit. So take a look at this. What do we have here? We say that tangent theta is equal to 2y. Our y ranges between 0 and 1. So since y is between 0 and 1, if you plug in 0 for y, tangent theta is equal to 2 times 0. So tangent theta is equal to 0 and theta is equal to 0. If you say tangent theta equals to 2 times 1, because y is either 0 or 1, so we plug in 1, tangent theta is equal to 2 times 1 or 2. So theta is equal to inverse tangent of 2. For this value, for this number, you have to use a calculator to find this limit. So here you have 0 to inverse tangent of 2. So eventually we plug in everything here. After we plug in inverse tangent of 2, you have to use your calculator to find this value, to find the theta. You plug them all in. You get L equals to 1 over 4 secant of inverse tangent of 2 times tangent of inverse tangent of 2 plus ln of absolute value of secant inverse tangent of 2 plus tangent of inverse tangent of 2. Now minus, you have to plug in 0. Very well. If you have tangent of 0, this is sine over cosine, which is going to be 0. So you can ignore this term. It's going to be 0. You only left with ln of absolute value of 1 over cosine of 0 is equal to 1. So you get ln of 1, which is 0. So if you simplify this guy, you eventually get square root of 5 over 2 plus ln of square root of 5 plus 2 over. This is the length of our curve. And this is square root of 5. You want to find note chapter 7. Suppose you want to find the integral of secant cube theta d theta. So first of all, you can split this and write it as the integral of secant squared theta times secant theta d theta. So let us apply integration by parts. U secant theta dv equals to secant squared of theta. Let me form that little table for you. U dv du and v. U is secant theta, dv is secant squared theta, d theta. So du, the derivative of secant, secant is 1 over cosine, so you get negative cosine theta raised to negative 2, and the derivative of cosine is sine, so you get plus sine theta. How do I take the derivative? Here I have cosine theta raised to negative 1. I'm taking the derivative. I have negative cosine to negative 2 theta, and the derivative of cosine is negative sine. That's how I get plus sine theta. So if you simplify this, you get sine over cosine tangent times secant. Tangent theta, secant theta, don't forget here you have d theta as well. And the integral of secant squared. The integral of secant squared. This is the integral of secant squared is equal to 1 over cosine squared. So here you have 1 over cosine squared. It means that we can write this as sine squared plus cosine squared divided by cosine squared, so you get tangent squared plus 1. And you can eventually simplify this integral. The tangent. We don't need constant of integrations here. So V is tangent theta. Okay, very well. So integral of secant to the third, integral of secant to the third theta can be written as uv secant tangent minus integral v du. Tangent times tangent is tangent squared times secant theta d theta. There we go. Okay. Now take a look at your tangent squared. Tangent squared of theta is equal to secant squared minus 1. So the integral of secant to the third theta, d theta, you copy down these two, which is secant times tangent theta minus the integral. Instead of tangent squared, I'm going to write secant squared minus 1 and create secant cube one more time. So I have secant squared theta minus 1 times secant theta d theta. Now I'm going to distribute secant into the parentheses to create the integral of secant cube again on the right hand side. Very well. Box for you. The integral of secant cube theta d theta is secant theta tangent theta minus the integral of secant cube theta minus secant theta d theta. Very well. I have the integral of secant to the third of theta d theta equals to secant theta tangent theta minus the integral of secant cube theta d theta plus integral of secant theta d theta. Okay, so what I'm going to do, I'm going to take this guy and add it to the left-hand side, like a just normal equation. So you get 2 integral of secant cube theta d theta, which is equal to, so secant theta tangent theta plus integral of secant is just ln of secant plus tangent. Since I have 2, and my goal was to find the integral of secant cube theta d theta, I wanted to find this integral. I have to divide everything by 2. Divide by 2. So integral of secant cube d theta is equal to 1/2 secant theta times tangent theta plus ln of absolute value of secant theta plus tangent theta. Another example for you on page 3. So question says find the arc length of function y equals to x squared minus 1 over 8 ln of x, then x start from then function y taken from point 1 and 1 through the string point. As the string. There you go. What we know that the length is equal to the integral a to b square root of 1 plus the derivative of the function raised to the second power. So we need the derivative of the function to the second with respect to variable x. So since you have ln of x, it's better to take the derivative with respect to x. So since y is equal to x squared minus 1 over 8 ln of x, the derivative of your function is equal to the derivative of x squared is 2x minus 1 over 8 as coefficient. We copy down the coefficient, and the derivative of ln of x is 1 divided by x. Let's simplify this. Y prime is equal to 16x squared minus 1 divided by 8x. Very well. Our L is equal to the integral. So I expect you to ask, what is the lower limit? What is the upper limit? This is the beginning point. This is your A. Your V is just a variable. So your A is 1 and your V is just a random variable, let's say x. And the integral 1 plus the derivative. What is our derivative? The derivative is here, raised to the second power. So here you have 16x squared minus 1 divided by 8x squared with respect to x. Here we go. Let us continue. So this is our L. Our L can be written as the integral, guys. I changed the upper limit to alpha for new variable so you don't confuse x and alpha. 1 to alpha, and you have square root of 1 plus. Okay, let's see. What do we have here? We have a component inside. If you simplify this, you get 2x minus 1 over 8x raised to the second power. So it means that you have a minus b to the second, which is a squared minus 2ae plus b squared. So this guy can be written as 4x squared minus 2 times 2, 4 divided by 8, a half minus a half plus 1 over 64x. So the quantity inside parentheses raised to 2 is this expression here. So let us write this here inside the radical. 1 plus 4x squared minus a half plus 1 over 64x dx. 1 minus a half is going to be plus a half. So L is equal to the integral 1 to alpha square root of 4 x squared, I'm sorry, this guy has x equal 2, I have to write this down, plus a half, plus 1 over 64x squared dx. There you go. Take a look at this expression inside the square root. This is equal to 2x plus 1 over 8x squared. So my L is equal to the integral 1 to alpha square root of 2x plus 1 over 8x to the second dx. It was an expanded form. I rewrite this in compact form. Now you can get rid of square root. L is equal to the integral 1 to alpha 2x plus 1 over 8x dx, which is super easy for you to find this integral. So I'm going to write down the rest of it here. This is going to be L equals to the integral of 2x is x squared plus 1 over 8 ln of absolute value of x, and my x ranges between 1 to alpha. 1 to alpha. So first I plug in alpha, then I plug in 1, then I do the subtraction. L is equal to alpha squared plus 1 over 8 ln of absolute value alpha minus, now I plug in 1, I get 1 plus 1 over 8 times ln of 1, which is 0. So L is equal to alpha squared plus 1 over 8 ln of absolute value of alpha minus. Okay, let us talk about center of a mass. Eight and 3. So 8.3 center of an object. Okay, very well. Suppose you have a two-dimensional object, and your goal is to find the center of this object, 2D object. What would be the center of this object? So the center of the object, for example, suppose this point represents the center of your object, it's denoted by x bar and y bar. Let A be the area of the object, then x bar and y bar for this object that you use function f of x to create this function, to create this object in two-dimensional space, follows the formula 1 over 8, the integral of x times f of x dx, x ranges between a to b, and y bar, the y coordinate of the center is equal to 1 over a integral of f of x squared dx a to b. And don't forget to write 2, 1 over 2a. For example, the question says, find the center of of mass of a semicircle. With radius r. So suppose you have a semicircle. This is your semicircle. And suppose it's located at the origin, the center is at the origin, and the radius is just r. Perfect. So we need to find x bar, and we also need to find y bar. First of all, the area of a circle. Area of a circle. It is pi r squared. So the area of half a circle you just take the area and divide it by 2. You get pi r squared divided by 2. So we don't have any problem with a and a. These are just values, constants, numbers. R is just the radius. Radius is just a number. So area, half the area, these are just values, constants. So your goal is to find f of x. What is your y? What is your f of x? Recall that formula for a circle with center at the origin, 0 and 0, with radius r is x squared plus y squared equals to r squared. Since you're working with half a circle, above x-axis, your y squared, which is r squared minus x squared, y is square root of r squared minus x squared. This is your y, square root of r squared minus x squared. Very good. Let us continue. Okay, so we found our function f of x. Now we have to find x bar, then we have to find y bar and see what's going on. So x bar is equal to 1 divided by a, 1 divided by pi r squared over 2 integral. Okay, your x ranges between negative r and positive r. Negative r to positive r minus r to r. And remember that we have symmetry here. And inside the first integral, you have x times square root of x times square root of r squared minus x squared dx. You're lucky here. You can use u sub. You can take u as r squared minus x squared and done with your integral. Negative 2x dx. So x bar is equal to, I'm just going to flip this to divided by pi r squared, and I'm going to write this guy as negative 2x. So I'm going to divide this by negative 2. I already have this, so let me just plug in just negative 1 here. And I have square root of r squared minus x squared dx. This is equal to, this is x bar, negative 1 over pi r squared, and I have integral of square root of u d. So I have negative 1 over pi r squared, and here I have times 1 over 1 plus a half u, which was r squared minus x squared raised to 3 halves, negative r to r, or I can just write this as 0 to r and multiply the whole thing by 2. 0 to r multiplied by 2 because of symmetry. I'm just finding this part here and multiply by 2. There you go. Okay, look, if we plug in r, you get r squared minus r squared, which is 0. So the only thing is left is 0. You have 2 over pi r squared times 2 over 3, and if x is equal to 0, you get r to the third. So you have 4 r cubed divided by 3 pi r squared. So if you simplify this, you get 4/3 r over pi. This is your x bar. Now for y bar, again we have 1 over 2a, so y bar is equal to, let me erase x bar, so I have enough space to write down here. The y bar is 1 over 2a integral a to b f of x raised to the second power dx. So the second coordinate is equal to 1 over 2a. So what is our a? Pi r squared over 2. So pi r squared over 2 integral a to b negative r to r x squared. So here we have the square root of r squared minus x squared raised to the second power. In the formula you have x times 2 dx. So you can easily get rid of radical. You get y bar equals to 2 over pi r squared integral negative r to r squared minus x squared dx. I'm going to do the same thing. I'm going to change the lower limit to 0 and multiply it by 2. So my y bar is equal to 4 divided by pi r squared. The integral of r squared with respect to x is r squared x minus a third x cubed 0 to r. So if you plug in r here, you get y bar equals to 4 over pi r squared. Here you get r cubed minus r cubed over 3 minus, if you plug in 0, both of these are 0. So minus 0. Here, if you simplify, you can factor out r cubed. R cubed divided by r squared is r. So far you have 4 r over pi, and 1 minus a third is equal to 2 thirds. So the final answer is 8 r divided by 3 pi. Let's see, everything is good. Okay, 2. 1, 2 is missing. So we have 2, cancel out these 2. This is 1, so 1, 2 is extra. This is 2. So here we have 2, and here we have 4. I forgot to add 2 on the denominator. 2 and 2, they cancel out each other. There you go.